So this is in 2020, as you can see, May 10th, 2020. These are kind of like where I was at in terms of like being able to describe what I was calling zeta space. And as you can see, it's kind of naive and like very rudimentary. This was 5 years ago, by the way. So anyway, so just go through it. I say I would like to attempt to define a mathematical space, I call zeta space, where I then say it's a description as the transversal intersection of two isometric Riemannian manifolds, yada yada yada, both equipped with Lorentz metric, somewhat difficult to describe and derive zeta space because it's not standard approach. And I say it doesn't have a clean representation, blah blah blah. However, I think it is important to study. All right, so here's how I defined it way back 5 years ago. 5 years ago, as an intersection of these. So already you can see that I have that this is very different of how I define. It's very similar in spirit to like how I started thinking about like the notion of an F completion, a foliational completion. But here, I would change that. Nowadays, I would change that to a union. The intersection would be more of like a kind of a gamma set type object. But already you can sort of see like this is, yeah, if you take these, and if you set maybe, even if you set T there to S, so they're both S, then this really becomes like a kind of like my first example of a real analytic F completion, because as you can see, all the lines, all the leaves, so these are the leaves of 1, they're all converging to the cone points. There's another one, you can't see it because it's the same color, but you kind of see how it's going this way and converging to the cone points. So this would constitute the union of all those leaves. Would be, first example I have is a real analytic F complete.